Welcome to this training tackling the topic of querying versioned terminologies. How in SPHN a project can improve the accuracy of their data analysis. Several national and international terminologies are used in SPHN and provided in the format of choice RDF, the Resource Description Framework. Since data coming from hospitals or other data providers is coded with different versions of these terminologies, we investigated how they evolve over time. Particularly, we've put a focus on 3 of these terminologies: ATC, CHOP, and ICD-10-GM. ATC is the Anatomical Therapeutic Chemical Classification, which is provided by the WHO, the World Health Organization, and it contained approximately 6,600 codes in 2023. CHOP is the Swiss classification of procedures, provided by the Swiss Federal Office of Statistics, and it had around 18,500 codes in 2023. Finally, ICD-10-GM, the International Statistical Classification of Diseases and Related Health Problems, is also provided by the Swiss Federal Office of Statistics, and it contained approximately 18,000 codes in 2023. A short note on ICD-10-GM though. Originally, ICD-10 has been created in English and provided by the WHO. Then, the German Federal Institute for Drugs and Medical Devices, the BfArM, created, based on the ICD-10, the ICD-10-GM version, which is the German translation of these English codes, which also contained additional codes. And this ICD-10-GM has been taken by the Swiss Federal Office of Statistics to make the translation to French and Italian, which led to this ICD-10-GM we are using in Switzerland. And this is the one that is used also in SPHN. Our analysis consisted of analyzing possible semantic drifts between consecutive versions of these 3 terminologies. What we mean by that is that we want to identify the codes that may have changed in their meaning between 2 versions. Once they are identified, we annotate these codes in a machine-readable manner so that we can improve the quality control steps during the data preparation in the hospitals, but also increase the accuracy of the data analysis by the researchers, which now get another layer of information about these codes. But overall, we would like here to raise awareness to the SPHN community that semantic drifts are possible to observe and they should be considered when dealing with data containing different versions of terminologies. The baseline methodology applied for this study is to compare the labels of the same code between successive versions. A Yarrow-Winkler similarity score is calculated, which scores 1 if the labels are identical, and 0 if they are completely different and have no match at all. With this method, we wish to include all potential changes that are observed in these codes. In a second step, we did some pre-processing to ignore a few known non-semantic changes like removal or addition of spaces, HTML tags, brackets, and character cases in order to refine the calculated scores and therefore the results. First, we did the analysis with ATC from 2016 to 2023. As a reminder, it contains 6,600 codes in 2023. The graph on the left shows the changes that are observed between consecutive versions of a code without any pre-processing and by applying a cutoff of 1. The middle graph is the result after applying the pre-processing steps mentioned above or before, and the graph on the right is after the pre-processing step, but with a relaxed cutoff. We can still observe that some codes still did differ even when removing some of the obvious non-semantic changes and relaxing our threshold, which we can think are possibly reflecting some changes in the meaning of these codes. The difference observed between 2020 versus 2021 and 2021 versus 2022 after checking the files were due to HTML tags and spaces being removed, and therefore we don't see them in the graph B and C where we applied the pre-processing checks. When looking into more details in some of these codes, we observe 3 main kind of changes. Either we had no change in the meaning, and this code in 2016 had this label, which was updated to an extended version in 2017. With domain knowledge, we can infer that this label changed for clarity and to accurately represent the name of the chemical compound. As a result, we could state that there is, in theory, no change in the semantics for this code, although the label is different. Another type of observed changes is a code that has a split in its meaning. In the example shown, we have this code in 2015, which meant metropolol and other hypotensives. We can observe that the code did not change in 2016, it's still the same, but in 2017, we can see that the code changed to only be now representing metropolol and felodipine, while another code has been created for metropolol and amlodipine. So the meaning of the code C07FB02 got narrower in 2017. Finally, the last category contains codes where it is a little unclear whether there is a change or not. Computationally, it is impossible to assess if there is a meaning change. But even as a non-domain expert doing a manual check, it's difficult to assess if it is indeed a meaning change or not. So for example, this code in 2016 meant combination, but in 2017 meant potassium different salts in combination. We are not in enough possession of information to make a decision whether this is a real meaning change or if it is much more of a clarification statement. So datasets with codes from ATC from multiple versions need to be carefully handled. Next, we did the same analysis with CHOP, so from 2013 to 2023. As a reminder, the CHOP contained 18,500 codes approximately in 2023. And we seem to observe on average around 1,000 codes that are changing between consecutive versions, and among them a little than 500 on average seem to be good candidates for possible real semantic changes. When investigating further these codes that changed, we mainly observed changes related to renaming or clarification of the code labels, whether they were in French, German, or Italian. This is an example of the label of a code that got changed in German between 2014 and 2015. And therefore, if you know the language, it might be clear what the change is really about. Otherwise, it may not be obvious if the semantics did indeed change. Finally, the same analysis done with ICD-10 GM. Again, we had approximately 20,000 codes. And here you can observe that in general, we see less codes being changed between the versions compared to CHOP, for example, which had approximately the same amount of codes. But some consecutive versions do not have change at all, like in 2016 versus 2015. And the reason will be explained just after. The changes observed are also here related to language-specific changes. ICD-10 GM being in German, text did change, and it would require to know the language in addition to the domain knowledge to assess whether the meaning did actually change or not. The mismatch that was observed between versions where no changes were appearing is actually due to the fact that the VFS, the Swiss Federal Statistical Office, is using previous versions of the ICD-10 GM because they need to have some time for the translation. If you remember, the Swiss are actually, or the BFS, are generating the translation in French and Italian of the German version of the BfArM. Therefore, in 2018, the version that was released by the BFS contained actually the codes from the 2016 version of the BfArM ICD-10 GM. And that's why in some consecutive versions of the Swiss, let's say ICD-10 GM, we did not observe any changes because they were using the same codes as the one from the year before. This initial analysis guided and led us to the first implementation of our versioning strategy. This implementation can be detangled in 3 main steps, where we first define version codes for these terminologies. Then we apply an identity check, and finally we create a historized file, which is the main outcome of this study and useful for the SPHN stakeholders. First, we define for each code from each version of a terminology a versioned URI. That way, each code is uniquely identified. This example shows you the ATC code A02BX05 from 2017. Using the link, which is resolvable from the WHO, we are able to define this unique URI with the year information and, of course, the code information. Then we apply identity to the codes. The consecutive versions of a code are compared, and if the labels are identical, then we make the assumption that the code is identical in the meaning. To reflect this in the terminology file, we add an OWL equivalent class between the 2 versioned URIs of the code. If labels have any difference, we make the assumption that the code may have changed in its meaning, and therefore we do not have this OWL equivalent class connection. Then we create these historized files for these 3 terminologies. Basically, 1 turtle file per version is generated, containing all the codes of that version, but also the historical ones. So for instance, in the ATC 2024 to 2016 turtle file, we have the codes from ATC 2024, which are provided both with an unversioned and versioned URI, but we also have all the codes versioned back to 2016 with their all OWL equivalent class connections when they were identical to their consecutive version. These files are provided in the DCC terminology service. This slide shows you a snippet of the content of these historized turtle files with the example of the ATC code that we had previously. You can observe that the classes with the unversioned URI is linked to the 2024 version of the code through an OWL equivalent class. Then the 2024 version of the code is linked to the 2023 version because they had no differences in their labels. And this chain of information is propagated until a change was possibly identified. So how is this all useful for the stakeholders? Using version codes enable to increase the accuracy of data analysis, especially when it comes to terminologies that may change the meaning of certain codes. In SPHN, our pipelines have validation steps that take into account these historized information and provide warning for possibly old or invalid codes. Therefore, data providers that are using those pipelines can have those checks. Both the data providers and the data users can actually make an informed decision then, whether the data provider wants to send that data element, which may have a warning information, but also if this data gets sent, then the data user can also consider to take into account or not this data element in their analysis. So how such analysis was done prior to the version codes. If we take the example of a query where we want to see how many patients were administered with the metoprolol and felodipine drug, the data user would write a query, SPARQL query like this, where a patient should be retrieved with a drug administration event where the drug contains this active ingredients. As a reminder, the metoprolol and felodipine code actually only came into play in 2017, and prior to that, the meaning of this specific code was much broader. Before we had the version codes, there was absolutely no way in knowing if the substance was administered with indeed the metoprolol and felodipine code or if it was another broader substance. Now, with the version codes, the user can specify the version that they are interested in. So they can write in the query that they would like to get all the patients which had the drug administered, which is the metoprolol and felodipine drug, which has been valid since 2017. And if you remember, in the versioned or the historized file, we have a chain of information until a meaning change is observed. Therefore, with inference turned on, the query would retrieve your results where the data is annotated with 2017, 2018, 2019, etc. codes of the metoprolol and felodipine, and you would not receive the results where this particular code was provided, so the 2016 version of that code. In the future, we are envisioning some improvements in the way we are dealing with these historized codes. So currently, any change is considered as a possible meaning change, and it is up to the data user or the data provider to assess whether they consider that as a real semantic change or if it is just a non-semantic change information. Therefore, for the future, we can try to automatically detect real semantic changes versus what could be typo fixes. Another step would be to add more granular relationship between versions of a code, so having these narrower or broader information statements to state that a code became narrower or a code became broader. But we could also check for structural changes in case a code moved from the hierarchy in the terminology. We could also highlight these changes. You're welcome to have a look at the following references for having more information, and thank you for your attention.